All right, so we'll go to page 2 here, and I'm about to teach you something called the line of best fit. And it's kind of funny. One time, an English teacher was in charge of giving our PLC group some help, and they were like, "You're saying that wrong. It's called the line that fits best." And it's like, nope. In math, this is the official name for this. It's called the line of best fit. And I get it might be grammatically incorrect, but that's what they call it in all of math. The line of best fit. And here's how it goes. If you graph these dots, they basically look like this, okay? And then you can draw a line through them, and then you can say what the equation for that line is. All right, I want to actually take a second and graph these. So for you to do that, I would like you to start the numbering on the bottom with an 11. Now that's weird. You normally start at 1, right? So you make a little squiggle right here, and then you can start at any number you want. I'm going to start at 11. Because, why? Because the youngest kid is 11. Now we'll know that it numbers 11, 12, 13, 14, 15, but don't number them all. It just makes it messy. This will be 12, 13, 14. Maybe you like number every third one or something. 15, 16, 17, 18, 19 is our biggest one, so let's stop there. Okay. And then 10, 20, 30, 40, 50 up the y-axis. So your job here is to just put dots. It's called a scatter plot. The plot is just a bunch of dots. You got these numbered? That you're supposed to be doing right now. And then we're going to put the dots in the right spots. And then, the calculator could do this. But it's so important for you to understand it that I want you to do one by hand. And we'll put the dots in together in a second. All right. If you have numbered it, raise your hand if you're done numbering. That's most of you. All right. Catch up if you haven't. And now 11 goes with 18. I'm going to start on that end just because that's the smallest kid. Question, comment? There was a hand. Okay, forget it. 11 goes with 18, so I'm going to go up to 18. And I know it's not on here, but I know it's under 20, so that's good enough. 11 goes with a little less than 20. Sophia, you still with me? Good. You graphing these dots? 11 goes with 20. The next one is, and you can do these in any order you want, but I'm doing the 19 goes with 47. That's the other end. 19-year-old, 47. That's just a little less than 50. I think it's about there. 13 and 27. Do them all. All right. Is this a perfect line? No. I want to remind you about yesterday. Yesterday, we were talking about if you draw a line through this like this, the question would be, was it perfect? Was it all on a straight line? And then it would have been an R value of what? Anybody remember what perfect was? 1. What if there hadn't been any correlation? The dots were just all over the place. Then there would have been an R value of 0. And in between would be something like, well, it's either strong correlation if it's like close to 1, or moderate if it's kind of in the middle, or weak correlation if it was closer to 0. Okay, so that's R value. So on the test, side note, R is 0.89, but it's negative. You could tell me two things about this. You could say it's strong correlation because it's close to 1, but what kind of correlation is it? Negative. Would you be able to do that? If I gave you an R value, would you be able to say that's what that means? Yes.
What number would you say it would be like a moderate correlation?
All right, what they gave was basically thirds. So from 0, which is no correlation, to about 0.33, that's about a third of the way. That's weak. From 0.33 to 0.66, and again, I think they use 0.65. That's close enough, though. I'm never going to try to trick you on the exact borderline. But this would be moderate. And then anything above the 0.66 all the way to the 1.0 in there is strong. Okay? And then just remember it's positive and negative. It's easy to just miss that negative sign. Negative means it's going down like this. There are things that go down, like over time, your memory. Now, there are exceptions. I remember this, I met this guy named Russ. He was 92 years old, and he was an old ex-cop, and he could still recall the phone numbers of his informants he used to have in Minneapolis like 40 years ago. He could tell you what their phone number was. Okay, so not every old person loses their memory, but over time, generally, people's memory gets worse and worse. You get to be like 90, you're happy if you remember your name. I'm just teasing. But there's definitely a correlation with age and memory. I've noticed it myself. It's harder to memorize kids' names than when I first started teaching. A lot harder. Like way harder. I used to, when I was a new teacher, I would go up to Wolf Ridge, which does this long bus ride away. And on the bus ride, I'd memorize all 60 kids' names that were on the bus. Easy. I just knew everybody's name. It wasn't super easy, but I could do it. Now, I'd be lucky if I remember like 8 kids' names out of 60 if I took that same bus ride. It's just way harder. I can do it, it just takes longer. Okay, so my point, sometimes there's things that go down, and that has negative correlation. All right. Now, we have to learn how to make the line that goes through these. Now, any idiot can draw a line through dots. But I just want to remind you, draw a line through your dots that's kind of goes through the middle of most of them. You don't want to squiggle around. You want to keep a straight line, but draw a line that goes through your dots. That's called the line that fits best if you were an English teacher. Or in math, it's called the line of best fit. Okay. Now, your calculator is going to give you the equation for it, but I'm just going to give you this equation because, look, it touches here at about 13, so I could figure out the y-intercept. And then I could figure out the slope. It's like how much does it rise and how much does it run? Because I could give any equation, y equals mx plus b. You remember the deal where the slope would go here and the y-intercept would go here? So I could get it from this. It would just be kind of a pain. And this is the part where the calculator will do it for us. So we are going to take that same data, same exact data right here, and we're going to put it in on L1 is this one, and L2 is this one. Now, if you were absent yesterday, you got to pay a really good attention because they all learned how to do this yesterday. Go to Stat button, and the Stat button is, man, this is so fuzzy. There it is. There's the Stat button. So go to the Stat button, and then you go to Edit, Stat, Edit, and put in this data. This is L1, this is L2. I'm going to pause, make sure everybody's on track to putting that in on the Stat Edit menu. So, almost everybody had it, but now I think everybody is putting these numbers in the right spot. One quick note, make sure that you put it in on L1 and L2. Every now and then, some poor kid puts it in on L2 and L3. Make sure yours are actually on L1 and L2. Okay, then go to Stat, Edit. Nope, I'm wrong. Sorry. Stat, Calculate, Linear+Reg. There's 2 of them. You go to the first one that you see, and it's y equals ax plus b. Unfortunately, nobody told TI that this would be really annoying. They should have an mx plus b. Yes, diagnostics should be on. I totally know that some of you probably have to do that again because you just downloaded the calculator's from the iPad, and those calculators have to be told every time. Put your diagnostics on. And if you don't have the diagnostics on, it won't tell you the R value, which will be necessary on today's homework. So, let's get to this part. Here it is. Here's the exact same data as you have, and yours should look like this. If you're like, but I don't have the R value, take a second, go to Catalog, it's above the 0, and find Diagnostics on, and do it. Hit Enter on Diagnostics on. Because otherwise you won't have this R value, and some of the questions require the R value. And it's so easy. Just find it. It's listed there. You just type it in. So if yours doesn't say R value, go put your Catalog Diagnostics on. Okay? All right. Now this is the important part. So I get there was a lot of like downtime while I was checking people's calculators. Focus. Lock in. Everybody write on your iPad notes. Write y equals 3.10x. Write that. Right now. On your on your notes. Why? Because this is the equation you have to write to get the credit on your homework and on the test. That's not an equation. Well, it's close. It just has to end with a number. Plus what? Well, see, it's this equation, and they're telling you the A value, which goes here, and they're telling you the B value, which goes there at the end. So what do I do at the end? I put that. And I'm just going to go to 1 decimal place. Negative 16.9, actually. Now, do you put plus minus? I wouldn't mark it wrong, but for the Schoology quiz, you're only supposed to put in plus or minus. And if it's plus minus, do you get that minus wins? It's true. So then it's really just minus. There is the precious equation the calculator's trying to tell you by telling you the A value and the B value. They're trying to tell you, here's your equation. I wish you could just type it all at once. Just do this, calculator, so kids can just copy it. But the downside of that would be that it doesn't know how many decimal places you want. So it gives you a really long number of decimal places, and you can put in what you want. Okay, so here's your equation. Now, here's the important part. You're going to be asked a question about it. First of all, what is the equation? Well, I just showed you how to get it. It's this. That's the equation. But secondly, what if they tell you that x is 20? Well, you'd put it in for x, and you could figure out what y is, right? You'd do a 3.10 times 20 minus 16.9. I wish it was that easy where they just say, hey, by the way, x is 20. If it was, this problem would be like a no-brainer. But this is the last lesson that you have to learn for higher algebra. And this is the class that's required by law that you pass in Minnesota. This is the highest level that you have to take. And this is your last lesson of the last class you have to take in math. Now again, many of you are going to take another math class after this. You should take 4 years of math in high school. Once you get to pre-calc, then most colleges are like, fine, you don't have to go further than pre-calc. But if you aren't to pre-calc yet, which clearly you guys aren't, then you should finish with pre-calc before you be done with math. And I think you should keep taking math all the way into college, but I might be biased. Okay, so back to this. They're not going to just tell you x is 10 and stick it in. They're going to say something like, his age was 10. And you're going to be like, I don't know where to put it. You have to go look up and see if age is x or if age is y. And I can't tell. I don't know. I'm going to go up here into my data and figure out which one's my L1. Ooh, there's my L1. That's x. The top one, that's x. So that means if they give me an age, I should put it in for x. See what I mean? They'll give you a number. You're supposed to stick it in. You know that, but you're like not sure where to stick it in. That's where the hardest part is if they tell you age, you'd have to look it up and go, oh, I guess that was my L1. So it was the X. So if my age was 10, I would put it here. And then you could use a calculator to go 3.10 times 10 minus 16.9. What's the only other place you could put it if it wasn't going to go in for X? Y. And in that case, they would be giving you a distance thrown. All right? So if they gave you a distance thrown, like the kid threw it 50 meters, well, then you put a 50 right there, and you could solve it. See, that's an equation. You've been solving equations since 2 years ago, maybe 3 or 4 years ago. 50 equals 3.1 x minus 16.9. You could solve that, couldn't you? Just add 16.9 to both sides and then divide by 3.1, right? So when they give you a number, you either put it over here where the y is, or you put it in here where the x is. That's the hardest part. All right, I want to end, since this is my last lesson for you guys, I want to end by giving you one more set of data on an L1 and an L2 and have you put it in, find the equation, and see how you could actually use it in real life. Every now and then in Florida, somebody is paddling around out in the water and they've come across a dead body. I know. Disgusting, but it actually happens. They might find just like an arm. And you might think, well, how can you identify a body from just the arm? Well, if there's a tattoo on it, that helps. But if there's no tattoos and it's just an arm, what you can do is you can take the length of the bone. Let's say it's one of your arm bones. I think one of these is the humerus. Does anybody know which one? Is that the top one? The top one? Okay, so the humerus bone. You've got this bone, and you can look it up that there's an equation for that. And it's like the bone length and then the height of the person. Why would that help? Because if you can look it up on the chart and go, oh, if the bone was this long, the person was probably this tall, you might be able to go, oh, that came from a person who was 6'2". And then all of a sudden, you can narrow it down, and it can't be this person or that person or that person. They go through the missing persons list then, and they go, oh, couldn't be this person or this person or this person. But there was a guy who was 6'2", who was missing, and then they can maybe go, oh, maybe it's him. And then they can go back to his home and find a hairbrush and get some follicles of hair and run DNA tests, and then they can check the bone's DNA, and they can be like, yep, it's him. All right, so my point, if you just found the length of a bone, you can look up and see how tall the person would be. So I'm going to show you how that would be done. We're just going to have 3 people, and I'm going to measure their height and their finger bone. And then we're going to be able to show you how that would work. All right, so Marcel, would you come up? You're one of the taller guys in here. I need somebody tall, and then somebody like medium height, and then somebody short. And you stand right there. There's his meter stick stacked up. Let's go a little bit further that way, because I'm going to try to put this up there. And perfect, thank you. So you can step back and see this. You are 100 for this meter stick, plus 70, plus 7, 177. Now, would you hold out your thumb this way? I'm going to measure just the end part of your thumb. 3.3. I'm going from the middle of the knuckle. 3.3. Perfect. Thank you very much. 177, did I say before? Right?
I think so.
Is it 177? Okay, good. So, do you see how there's a correlation there? Now, if I found a bone that was 3.3, this is like the knuckle bone, okay, from the end of his, from his last knuckle on his thumb to the tip of his thumb, that part, okay? So, if I found one that was 3.3, now I'd know I'd be looking for somebody about that tall. See what I'm saying? Now, do you think one person is enough data? No, you got to have at least a few. All right, so I'm going to get a tall person, a medium person, and a short person. All right. You're really tall. Would you be willing to come up? Yes. Thank you. And then some short person that's bold. I would love to have you let me measure your height in centimeters. All right, so just turn back to this. Perfect. The gentle giant. I'm going to pinch your hair. There, good. You can step away. And you are 192. Okay, so everybody write down 192. And then thumb this way. Bend it. There you go. All right. 3.5. Thank you very much. Now, does that make sense? Yeah. Okay. Please. Just I want this to be real. Thanks. Come on up. And back to that. Perfect. Move that way a little bit. There you go. Whoop. Thank you. You can step away. 161. I'll ignore the nail. Without the nail. And that is 2.9. Thank you very much. And what was her height again?
162.
162. Does that make sense? Height's a little lower, thumbnail a little bit, not nail, thumb length. The last digit, last part of your thumb, 2.9. Cool. All right, so now, everybody take a second. Put these three numbers in your L1, put these three numbers in your L2, and we'll get the exact equation for a high school kid. Their length of their finger and the height. And you know what? It's going to probably stay proportional. Meaning, if you continue to grow, and you get taller and you become an adult, it probably means that your fingers are probably going to grow a little bit too. It'll stay proportional. You know, one thing that doesn't grow, I have heard, and I could be wrong on this, your eyeballs. Now, again, I could be wrong on this. Totally can Google me on this, and I'll probably find out I'm wrong. But that, it was said to me, and it made sense to me, that that's one of the reasons that babies' eyes seem so big. Is that if their eyeballs are the same size as when they're an adult, that would, you get how that would be, make their eyes look big? All right, anyway. And again, maybe it's one of these things where it grows, but it doesn't grow that much. Maybe the eyeballs are mostly as big as they're going to be or something. I don't know. All right, so back to this. Have you got those entered? Now, do you know how to do stat, calculate, Linear+Reg? If you do, write the equation that we get for our class for this data right here. Stat, calculate, Linear+Reg. Yes?
When you already have them typed in, how do you take them out?
Oh, DEL for delete, the DEL key. Then please write the equation, and let's use 2 decimal places. Like, I know it's not 2.9, but like whatever this is, and whatever this is, let's go with 2 decimal places, like 2.91 and 4.93. Okay, you got that? I'm just starting now. So if you're like, but I got behind, you can start right now. Still finish the same as me. Stat, calculate, Linear+Reg, enter, enter, enter. And I get y equals negative 0.31. I rounded right, did you? X plus, and the B, ah crap, I put the negative 0.31 in the wrong spot. Sorry. The 0.31 goes at the end. The A value is 0.02. And then the negative 0.31 goes here. And remember, plus minus really isn't a thing. Plus minus means minus. And there it is. So that part I feel like is pretty easy if you can just figure out that A goes here and B goes here. Like, Do you agree that that part's easy? Just type it in. It tells you. But here's the hard part. Will you know what goes where? I give you a height. Where would you put it? Yep. How did you know it goes in X? It's just every time they give you something, you put it in X? L1 is the X. Yep. That's the X. And since I gave you a height, so if I give you a height, let's say we find some person and they're missing their hand. Ooh, could happen. And their height was 150. Well, I could put that here and use the calculator to multiply this and subtract 0.31, and it would tell me how long their thumb bone should be, their little end bone. Okay, and lastly, this was the one that was the hardest. There's one question like this on your homework, and my guess is it'll be on the test also. What if they don't give you the height? What if they give you the length of the finger?
Why?
It goes in Y. Some kids thought it should go at the end. No, the Y, it's here. So if they give you that the finger bone was like 3, you could put it right there, and then you could solve this. 3 equals 0.02x minus 0.31. You know how to solve? This is a moment where you got to just go, I guess I know this. I could just add 0.31, and then I divide by 0.02, and you could solve that, right? So there's only 2 places they can ask you to put stuff, in the Y or in the X, and you got to figure out where it goes. Okay, that's it. You just learned the last thing you have to know. That's called a linear regression equation. And your test is not tomorrow, but it's the next day. Strong encouragement. Stay locked in for literally 36 hours, and then you'll get a good grade on this test. It shouldn't be that hard. It's mostly about how to use your calculator. And then your math life will be so easy. If you can just stay locked in for another 36 hours, that means you'll be through the test tomorrow. You'll be all ready to go. You won't have to repeat it. You won't have to do corrections. No retake necessary. No coming in the morning for that. Just lock in on this test. Get it done. And then all you'll have to do all of next week is review. Review, and then the final. And I have some good news about the final. It's not going, we checked through it, and it's not going to be the R3 versions of the questions, meaning that you'll just mostly have to remember a lot of the easy questions. Know what I'm saying? Does that mean it's easy? No, but it's easier than it would have been. Okay, so it's mostly a bunch of R2 kind of problems. But we score it like a normal test on a simple percent. We give you a whole batch of easy problems, and then you get a 90%, then you get a 90%. If you get an 80%, you get an 80%. It's super simple in that respect. But again, it's hard to remember so many concepts, so we'll review with you. But all right, now, please start right now. If you're started with your Schoology quiz, you'll be halfway done. Open up the Schoology quiz. Don't take out your phones yet. We're close. The first thing you got to do is enter some data. They give you some data. Get your Schoology quiz open, please. I expect you to start it. I can't control whether you finish it, but I can make sure you start it. All right. For number 1, let me push it back a little bit so I can see it. Thank you. So it looks like mass, which is L1, going across, and then length, which is going to be L2. And then they got 0 and 50 and etc. 17.7 and 20.4. So enter in all your data, and then what's the first question about it? Use technology, their least squares regression line, that's what we just did, linear regression. In the form y equals ax plus b, so everybody, I can guarantee you, the first thing you type in that blank is y equals. It's an equation. That's the first part of the first answer, y equals. And then you got to figure out what the x is. And then you got to figure out what the number is that you add at the end. And those come from the calculator doing hard work. Then it's going to ask for the r value. And I would bet money that some of you are like, I forgot how to do the diagnostics thing. Walk up, I will literally do it for you. Okay? So if you get stuck on mine doesn't have an R value when I do the regression equation. I'll turn on your diagnostics for you. It'll just be faster. Because they have their own calculator, once they turned on diagnostics, it just stays there forever. It's kind of an unfair advantage of having your own calculator. So I'm willing to fix that by, I'll do your diagnostics on for you if you don't know how to do it. It's under catalog, diagnostics on. All right, that's all I got for you for today.